Hello friends, I am Nipun Parekh. Today I am going to explain you about transistor as a current mirror, transistor as a logic gate and transistor as a voltage regulator. The logic gate. The load line defines saturation at the point where the current is quite high and the collector to emitter quite low. The resulting resistance defined by RSAT. Voltage supply by current is quite low and is often approximate at the short circuit. At cutoff, the current is relatively low and the voltage near its maximum value is shown in the resulting in a very high impedance between the collector and emitter terminal, which is often approximated by an open circuit. This is the graph of this. The saturation region is called that when the current is maximum is called as saturation region. Cutoff region means when the voltage is maximum is called as cutoff region. The AND gate. The AND gate often requires that the output be high only if input have a turn on voltage supply. Means that AND gate requires only high output supply, not high or low. The AND gate requires only high supply. If we are giving in one terminal 0 volt and in second terminal 1 volt, then also the circuit will not work. The circuit diagram of AND gate. In this I have taken three resistance, 2 transistor and 1 voltage supply. Now we will move to the multisim part. Now we are moving to the multisim part. This is the circuit diagram of AND gate. As I told you, this is the circuit diagram of AND gate. In this, I have taken 2 resistor and connected to the voltage supply. As the AND gate specification is that if we are giving both terminal high voltage, then and then only we are getting the output. So we are doing theoretical that we are running the circuit. Here there is a 0 volt supply, so there is a 3.599 volt. That's nanovolt, so it is negligible. So we can call it as 0 only. If I am changing that one terminal I am giving to 1 volt, let's see about that. Then also we are getting this 0 volt. So now at last we are trying to give high voltage at both the terminal. So when we are giving high voltage, then we are getting that output at approximately 373 millivolts. So now let's move to the second part, transistor as a voltage regulator. Transistor is a voltage level indicator. In this circuit, I have given the 9 volt supply and I have taken 3 resistor and 1 LED and 1 Zener diode. Now this is almost based on theoretical, so we move to the multisim circuit. So this is a circuit of transistor uses and voltage regulator. Here I have taken 3 resistor, 1 green LED and 1 Zener diode of 4.7 volt breakdown, and here 1 transistor. There are many transistors available of different breakdown voltages, but I have taken 4.7 volt Zener diode. So now I am giving 9 volts and I am playing this. So here the LED gets on, but if we are giving less than 9 volts, then the LED will be not on, because there is a breakdown voltage of Zener diode is 4.7 volt and breakdown voltage of transistor is 0.7 volt. So by adding this, we are getting approximately 5.4 volt. But in practical, there is almost more than 8 volts we have to give for the on the LED. So we are trying to change the voltage is, I am giving the 5 volt supply. Now let's see, the LED is not on because due to the less amount of voltage is present here. So this is our second circuit. Now let's move to the third part of our transistor used as a current mirror. Yes, this is a circuit of the transistor used as a current mirror. In this there is a voltage supply. I have taken one variable resistance, one load resistance and two transistors. And this is a graph of this current mirror. Yeah. The network also has a measure of built-in control that will try to ensure any variation in load current will be corrected by the configuration itself. For instance, if IL should try to increase for whatever reason, the base current of Q2 will also increase due to the relationship IB2 is equal to IC2 by B2. We find that an increase in IB2 will cause voltage to the increase also. Because the base of Q2 is connected directly to the collector of Q1. Here the Q2 is transistor second and Q1 is transistor first. The voltage VCE1 will also increase, also the cause the voltage across the control resistance to decrease. But if IR drop, the base current IB will be dropped, causing both the IB1 and IB2 to drop also. A drop in IB2 will cause the collector current and therefore the load current to drop also. The result, therefore, is sensitive to unwanted changes and the network will ever effort. The result, therefore, is a sensitive to unwanted change that network will make every effort to correct. The entire sequence of event just described can be presented on a single line as shown as below. Note that at one end the load current is trying to increase and the second end the load current is forced to return on its original level. Now let's see on the multisim circuit. Yes. In this circuit, as I told you, I have taken one variable resistance, one load, two transistor and one voltage supply. Now let's see about that. So as I have told you all the components in the circuit, now we are doing practical of this. Okay. I am measuring the current across first transistor and second transistor. If I am changing this variable resistance, now, first of all, both are similar because it is less amount of current is present, so we can consider it as a 0 also. So here is a similar, but when I am going to change this, then also it will be remain similar. As I told you, if one resistor is trying to change its load, then other transistor is trying to keep at the constant value of current of both the resistance. So this is my third circuit. And the last. So as I explained you this IL is trying to varying, but this IL is trying to stable both the current of the transistors. Some important term of this. Thank you for the watching video.